Topic of this video is
C++ Tutorial 2 Unique Pointer Guarantees Uniqueness. In the last tutorial, I used an example to prove that unique pointer can prevent memory leaks by calling destructor automatically without explicitly using delete method. This feature is not unique to unique pointer. In fact, all other smart pointers in C++ standard library and boost library can do the same thing. The distinguishing feature of unique pointer is that it guarantees only one owner at any moment. You cannot assign a unique pointer to another pointer without losing the ownership. It's easier to demo this with an example. I will reuse the same program created in the last tutorial. Let's run it first and make sure the output is the same as before. Yes, they are. If we can assign the existing unique pointer P to another unique pointer, let's call it Q, then P is no longer the sole owner. Will it work? Let's find out. Define another unique pointer Q for class A. Assign P to Q. Build the solution. It fails with error C2280. It's not easy to read the message from Visual Studio output window. I copied it into this slide and highlighted the keywords like operator $, attempting to reference a delete function. Function was explicitly deleted. It basically confirms the statement, we cannot assign a unique pointer to another. You may wonder where this behavior is defined. Right-click on Unique Pointer and select Go to Definition. Now we are looking at the class template for Unique Pointer. Scroll down to the end of the block of code of this class template. It shows operator equal is defined as delete. That's why we got the error messages like attempting to reference a delete function. Function was explicitly deleted. These two lines of code are copied into this slide. Now we understand why unique pointer P cannot be assigned to Q. But what if we still want to assign P to Q? Can we do it? Yes, we can use function move to achieve this goal. But be aware that unique pointer P will lose the ownership in this process and becomes a null pointer. Let's see how this is done. Change the statement to move P to Q. Now run the program. The output shows P is empty as expected. P is no longer the owner. It lost the ownership. How about unique pointer Q? Since Q is not the owner, does it have the content of class object A? Copy the block used by P and change P to Q. And run the program. You see, Q's behavior is the same as P before. We have proved using move function, the ownership of P has been properly transferred to Q. Here is the first part of the code. The second part of the code. In this tutorial, I demoed an unique pointer guarantees only one owner at any time. We cannot assign it to another pointer directly with operator equal sign, but we can still transfer its ownership to another pointer with standard move function. In the next tutorial, I want to take a closer look at the template of make unique. Thanks for watching.